So my name is Daniel Pfeiffer, and I am the lead developer at Float. And Float specializes in custom mobile development for enterprises and government agencies. We've been growing a lot over the last couple of years, and it's been a really great journey, and actually a blessing for me to be a part of that. But as part of growing a lot, it means that my role has drastically changed, which of course means that my day-to-day responsibilities have also changed. So while I, at one point, spent most of my week sitting inside of an IDE, writing lots and lots of code, my time now, the number of lines of code I write in a given week has dropped dramatically, and it is very easy for my time to become consumed by coordinating with the QA team, or working with project managers, or sending builds to clients, or just overall coordination that it takes to build apps. It requires a lot of coordination, especially as the team grows. But the problem is that that's not what I want my week to look like. Some of the biggest joys of my week is when I'm able to sit down one-on-one with someone on my team and just talk through code with them. I want to be able to sit down with them and talk through a problem they're having, or just talk through how to approach a certain bug, or maybe a certain feature that they're working on. The time I spend in meetings working with the QA team, just like updating tickets, it robs me of the time that I get to spend with my team. And don't get me wrong, that those other things, like sending builds to clients, are very important. That those are things that need to get done. It's just not what I want to be spending the majority of my time doing. What's more is that these tasks are not like uniquely me. It does not have to be me doing these tasks. I certainly could have delegated them, but I'm not great at delegation yet, and so instead I decided to automate them. Maybe that makes me a really good delegator, I don't know. So today, to give you some insight, the Float team, which is still a small team, just in the last week, we worked on iOS projects, Android projects, mobile web. We're working with augmented reality, as well as even some experimentation with neural networks. And all of these projects that we're working on are releasing nightly builds to the QA team, and they have very frequent releases to our clients, sometimes as often as twice a week. And at the center of this is our automated process that we kind of internally call Floatbot. Now, Floatbot is responsible for building, testing, sometimes directly on the device, signing builds, generating release notes, incrementing version numbers, updating tickets, and ultimately responsible for shipping apps. Floatbot frees up my time so I'm able to work with my team members, but also frees up my team members' time so they can focus on developing some of the great apps that we're able to do. So my goal today is to show you how automated process has, I really think, revolutionized how we worked at Float. I really enjoyed working on them and getting them into place over the last year, and I hope that as I share some of that experience and what it is in detail, how this is working for us, you'll be able to see room where maybe some of these processes can improve your own development workflow on a given week. So the first thing I want to do is give a bit of a lay of the land, is some of the tools we use at Float. The first one is Git. Git is, of course, our source code control. If you're interested, we roughly follow the Git flow branching strategy to keep the master branch up to date with new features as developers are working on it. Our ticket management tool is Assembler, which also happens to host all of our Git repositories. We use Slack to help facilitate team communication. This is great for our remote workers, who are a very valuable part of our team, but are not always available in the office. We use Hockey App to distribute builds both internally as well as externally to our clients. And finally, we use Jenkins as our automation server. Now I'm going to be focusing on Jenkins during this talk, but the reason I brought up all of the other tools is that, first of all, I'll be mentioning them, so I wanted you to have a clear idea of what role they play in our workflow. But secondarily, we found that an effective automated workflow works where your developers work. See, Floatbot is not like a single application or a single process. It's actually many tools that just kind of collectively has gotten the name Floatbot. There's many set of components and many processes all working together to help automate the things that we do on a day-to-day basis. Now, Jenkins is probably the core of what we call Floatbot. Now, if you're not familiar with Jenkins, if I boil it down to one sentence, what I would say is that Jenkins is a really fancy cron tool. Or if I put it in non-developer speak, Jenkins is a way to schedule tasks. At its core, that's what it's very good at. Now, you might be wondering, why didn't we use Xcode Server or some of the other continuous integration tools that are out there? And the simple answer is that we work on more than iOS. We do Android, we do mobile web, and just for the sake of not having multiple processes for multiple teams, we wanted to have one tool that would be able to cover all of the needs of all of the teams in all of our applications. Jenkins does a better job at that. But the more complicated answer is that even if we did just do iOS tools or iOS development, I think I would still lean towards choosing Jenkins. Because while Xcode Server does a great job at building, some of the other parts of our workflow, such as updating tickets or distributing to clients via Hockey app, that's a little bit more cumbersome in Xcode Server. They're certainly possible. You can have pre-flight scripts and post scripts that are able to just run any bash script that you write. So you certainly can write your own script or upload something to Hockey app, but it's just a lot of cumbersome pieces that you need to fit together in order to get a truly automated workflow. Because I'm not just talking about automated builds, I'm really looking at how far can this automation extend into what it is you do. Because I truly believe that an automated workflow goes beyond just generating builds, but it facilitates team communication. So there are hosted solutions available for Jenkins. We don't actually use any of it. We just use an old Mac Mini that was from an old conference room. And honestly, before that, it was just running on my laptop. And the principle that I want to kind of pull out of that and give to you is that you don't need a fancy set of hardware or servers to begin automating your workflow. The same tool that you use every day as part of your active development process can also be part of your passive development process. You can run scripts overnight, they can create builds for you while you're sleeping. You wake up the next day and have a brand new build ready for you to go. You might be surprised at how many additional bugs or new ideas you have when you're not connected to the debugger. So Jenkins is actually really easy to install on a Mac. If you have Homebrew installed, you just need to type in brew install Jenkins. I highly recommend Homebrew. It's outside of the scope of what it is I'm talking about. If you don't know what it is, send me a Slack message and I'll give you an introduction on that as well. After you run brew install Jenkins, it'll tell you to run brew services start Jenkins, which sounds like great advice. And when you do that, it tells you that it has successfully started Jenkins. So if we pop open our browser and take a look at what's going on at localhost port 8080, see that Jenkins is running. I'd argue that was actually a lot easier for me to set up than Xcode Server was the very first time. So Jenkins is ready to work for us. So what I want to do before we dive into actually getting to work with Jenkins a little bit, I want to make sure that we have a shared understanding of some of the terminology that Jenkins uses. So first I want to talk about what a node is. And it's quite simply, a node is, you can think of it as just a single computer or a single server inside of this build automation network. So if you're going totally on, if there's a scale of simple to complicated, way down the complicated side of the scale, is you could have multiple computers working together to produce builds. And each one of them might be considered a node. Now each of these nodes are going to have executors. These are what actually kind of do the work that you want Jenkins to do automatically for you. So it's not just going to just spew out and run everything all at the same time. It's going to queue things up inside of a build executor. And what you define is a job. This is what Jenkins does for you. This might be building your Xcode project. This might be uploading Hockey app. This might be updating your tickets. And so as jobs queue up, Jenkins finds an available executor and puts the job on there and lets it run. And when it's complete, it will post the results back, and you can do with those results what you want to. Again, maybe that is reporting to a Slack channel, or maybe that means that his email notifications get sent out. Again, you don't need complicated sets of servers to get started with this. You're just getting started. All you really need is one node. That can be your laptop, one executor. Jenkins comes pre-configured with that, and just one job. Now, when you first install Jenkins, it's not going to have a lot of utility maybe right out of the box. It might not look like it. And actually, I really think that's one of the strengths of Jenkins, is that all of its functionality is provided in plugins. That's what makes all the additional functionality and features that you want to be able to automate. That's what makes it easier for you to do. These are just some of the key plugins that we use at Float. We use many more than just these. But if you're just getting started, these might be a good set to take a look at. Certainly the Xcode integration one is an obvious choice, since that's what's going to let you build your iOS builds. But we also use the Hockey app plugin to get things uploaded to Hockey app automatically. And this has been far easier than writing a custom script to upload something to Hockey app after an Xcode server bot runs. We have our Slack notification plugin, promoted builds. I'm going to go into detail on some of these, but just to give you a sense, like, this is again just a very small excerpt of some of the plugins that we use, and there are many plugins available by the community. For the most part, if there's a service you're looking to integrate with, I would say there's a good chance that there's a plugin available for it. And if not, you can write your own plugin because it is all open source, or you can always fall back to just doing bash scripts. Because again, at its core, Jenkins is just a really fancy UI for running bash scripts. So, by way of setting expectations, when you set up your first job, it might not work right the first time. And honestly, it's because building for iOS is hard. That code signing, that is probably what took me the longest to get right. As much as I'd like to say I got it the first try, it did take a little bit of time. So if you were just running your first setup on your local machine, hopefully it's going to be a lot easier for you, because I'm expecting that you already have a development environment set up, which means all of your sign-in credentials are stored in what's called your login keychain. And that is typically unlocked on the computer already when you are sitting in front of it, which means as the jobs are running, it's able to use that keychain, and you shouldn't have any issues. If you do get more complicated, there are other tools out there, are additional resources out there to help you get past some of this, and I'm also happy to continue that conversation with you later on. But without further ado, I want to jump into what it looks like to actually create a job in Jenkins. That way I have kind of a shared understanding of what some of the vocabulary is. I want to create a job for one of our iOS applications. So after you install Jenkins, and after you get it, your first admin user set up, you're going to come to a page that looks a little bit like this. And I would be remiss if I didn't kind of, as an aside, mention that one of the first things you should do is configure global security. For whatever reason, there is an enable security checkbox, and I cannot for the life of me understand why that option exists. If you don't know when I ever want to turn it off. Jenkins has access to all of our source code, and much of our source code has access to maybe some of the private keys or some of the public keys that we use for interacting with APIs. And as much as possible, I'd like to keep those private. So make sure that you configure the security in your Jenkins install. So with that aside, you're ready to create a new job. So part of your job is going to require that you give it a name. I'm just going to call this sandbox, and you give it a type of project. And for your first job, I would recommend selecting Freestyle Project, because this is just lets you what combines with your source code management, other build systems, and combining all that together to get a very human-friendly output at the end. So some of the options that it's going to give you, and there's tabs across the top. The first one is source code management. I only have one plugin installed right now, which is Git, which is appropriate since that's the only one that I'm going to be able to use right now. And I'm just going to type in just a local Git repository that I have running. And at its core, that's all I really have to do. I could hit save, and I could say build now. And after a few moments, you'll see in the bottom left that a job has shown up, and it is kind of hard to see over there, but it has a blue orb next to it, which means that it was successful, which is great. I did get it first try. But the key now, you might point out that I didn't actually have it do anything. All it did was check out the code, and it didn't actually do any building. So that's not useful. So let's actually make it do something. Before we make it do something, though, we need to tell Jenkins what's going to trigger this build to happen. All of your jobs can have build triggers, and this is what tells Jenkins to start this job. You can start all of your jobs manually. That somewhat defeats the purpose of what I'm talking about right now. And so it is great to see that Jenkins has a lot of build triggers built in. Some of the most common ones that we use are going to be something either like build periodically. This is like your standard cron job where you just give it a schedule to run always. The other one that we use commonly is pull SCM, pull your source code management. And what you might put in here, and this is very similar to a cron schedule, is I might say every day at 2 in the morning, for every day, for every week, for every month of the year, I want to run this. I want to check the source code to see if there's any new commits, and then I run it. Jenkins is going to recommend that I actually replace that 0 with an H, and that's to help it handle the load. If you had 30 jobs all running, and you want to say run them all at 2 in the morning, that would put a very significant load on Jenkins in the middle of the night for no reason. And so it recommends that you replace something like that with an H, so that it can choose how it wants to spread out its load. And it'll even tell you down below that the last time this would have run was this morning at 2 in the morning, and the next time will be tomorrow at 2 in the morning. Other plugins may define their own build triggers. So so we work with Assembler, and they provide a custom plugin that lets us have a build trigger when a new merge request is open, or a pull request. That would be another name for that. You can also define custom triggers. So if there's something that happens in your environment, maybe, for example, you're looking for a specific ticket to show up inside of your ticket management tool, that can also trigger a job to start for you automatically. Once you have your source code as part of your environment and you know when your environment's going to run, you need to provide some build steps. And I'm going to say Xcode, since this is an Xcode project. And it gives you a couple of options for you to define. And the only one that it really requires you to put in, and even that is not even required because you can have it build all targets, is to tell it what target to build. And so for the project that I'm checking out, it's just called Sandbox. Now I want to give it a couple of additional options because I want it to clean before build. We found this to be very helpful to make sure that we're not pulling in some accidental build artifacts that we don't want. And we want to pack and build this IPA. So we'll call it Sandbox. I can skip over the code signing and OS X keychain options, but in case you are on a machine that doesn't already have a development environment set up and doesn't already have Xcode installed with your developer profile imported, you can provide some custom options here. To give you some insight, we actually work with a model where we have one keychain per project, which lets us import specific provisioning profiles and developer profiles for each of our projects. Under the advanced Xcode build options, there's one other thing that I need to define, and this is just because of the way this project is set up. My Xcode project is not the project root, it's in one directory D. If you're familiar with the Xcode build command line interface, all of these things that it's having me provide are just options and arguments that you can pass to the Xcode build command line interface. Because underneath the hood, all this plugin is doing is providing a UI for this command line tool. And that's what Jenkins is going to run when I hit build. Before I do that, though, I do also want to show that you can provide your own versioning information to override what's in the plist, the info.plist. So I might manually put in a marketing version, and then I can also specify that my technical version, I can use an environment variable. And Jenkins by default has a handful of environment variables that it will have defined for you. One of them is build number, which is the current build number. I've already run this project once, and so my build number, I've already completed build 1, so the next time I run, my build number will be 2. So after build, I can also put in some post-build actions. This might be where I would, for example, upload to Hockey app, or maybe I would send an email notification. Because I don't have internet access right now, all I'm going to do is archive the artifacts, which this is just telling Jenkins is to keep this around for forever. This is a great archival tool for all of your builds, so you can go back if ever you need to. You recall that earlier I told it to pack and build an IPA. So somewhere in my workspace, I'm going to have a sandbox.ipa file. So I can type in this **/ which just is going to tell it to search everywhere in this workspace for something called sandbox.ipa. I will save, and I could wait for this to build automatically at 2 in the morning, but we would not have enough to talk about until then. So I'm just going to say build now. And after I do that, in a few moments, you'll see down below, it is building my project, and I can actually click on this flashing orb, and it's going to show me the output of everything that Xcode build is running through. Now, unless there's a problem, I don't find myself going into this output very often because it is extremely verbose, but really all I'm hoping for is that when it reaches the end, I'm going to see build succeeded, finished, success. And when I come back to the Sandbox project, I can see off to the left there that in my build history, I now have 2 successful builds. And you recall that I said that I wanted to archive my results. And there's my last successful artifact of sandbox.ipa. And again, this could have gone to Hockey app, this could go to email, this could go to your own custom, you could go to an FTP server. Any way that you were just deploying your builds, Jenkins is able to do that. All right, so now that you have a building, let's talk about what you can do to build on that. Because just having one automated build, at this point I really haven't done anything more than what Xcode Server can do, which is build something and then effectively keep the results around for forever. So let's talk about how we can build on that. So at Float, we have 3 different types of jobs that we set up for each of our projects. We have the CI, or the continuous integration job, we have the nightly job, and we have the release job. The CI job is triggered automatically when a merge request is open. I mentioned those build triggers, and that are one of the plugins that Assembly gives us so that we can automatically trigger this. This is great because what this is going to do is pull down the feature branch offered up by the developer, pull down the branch they're merging into, usually master, and it's going to try to merge those. If it fails, it will immediately reject the merge request and say that this does not merge cleanly. Please be sure to pull in master before resubmitting. It's also going to perform static analysis on the code. and it's going to run all the available tests for the project. And ultimately, it's going to generate an output file or an IPA file, and it's going to link this into the merge request. This is very helpful because after Floatbot reviews the merge request, we're going to have humans review the merge request. And being able to go to a merge request and have an already built application linked right there that you can download directly to your phone is very helpful because it provides context for what changes the developer has made. Sometimes when you're just looking at the change set, it can be hard to understand why the developer implemented a feature a certain way until you actually get a chance to test it and touch it on the actual device. Finally, it will either upvote or downvote the merge request based on whether or not it was successful or not successful. And the reason this is useful to us is because this provides an immediate review of new code, and it allows for human reviews to be focused on like the logic and maybe the security of what's being implemented, and not so much on this style of how the developer chose to implement it. So just as a quick aside, I do want to mention a manual part of our process, which is code reviews. And some of the reasons that we do it is because I honestly think it helps us build better apps. Because first of all, we are a team. And my goal is for that every line of code would be seen by at least 2 humans before it leaves the door. And it has nothing to do with whether or not we're trusting the individual developer, but it is totally because I want to make sure that we are succeeding and failing as a team. And I don't want any one person to be individually responsible for shipping something that's horribly broken or has some horrible security flaw in it. And the second reason is that we're a team of experts. And I honestly believe that each member of the team offers a unique perspective on some of the challenges and problems that we're trying to solve in our applications. And so I want to offer up the opportunity for other developers that may not be actively working on the project to be able to speak into maybe a different syntactical way to write something so that it makes more sense to them. And this also offers us the ability to have shared knowledge throughout the team. So that's the continuous integration job. The nightly job is, as the name would suggest, is triggered automatically each night, assuming there are new commits. If it is the weekend, it is not automatically triggered on Saturday and then again on Sunday because there would be hopefully, no new commits between then and Sunday. This also performs a static analysis, runs all the available tests, but at the end, instead of posting it to a merge request, it will upload the build to Hockey app so it can be distributed throughout the QA team. It also posts the notification in Slack. And I almost lost a very important point, which is that it also updates all the tickets impacted by the build. This is hugely useful to our QA team because as they come in and get a new build each day, they're able to very clearly see which tickets have been impacted by this build. That lets them know precisely what it is they're looking for. These are the things that we want them to actively look at, while they're maybe passively looking for regression issues that may have accidentally been introduced. So overall, the nightly build provides the QA team with an always up-to-date build. This keeps our feedback loops short so that as developers are creating new features, they're almost immediately getting feedback from another source that is not them and is not another developer. So someone else that is thinking about the application in a different way, maybe has some different context for how they are experiencing the build. So because we do mostly client work, we also need to be able to send builds to clients as frequently as possible. Well, maybe not as frequently as possible, but frequently for sure. And so we have a modified version of the nightly job, which is a promoted nightly job. These nightly builds are great because it gives cutting-edge previews into what is being created by the developers. But to be honest, sometimes we break the nightly job. Sometimes something goes horribly wrong. Two developers changed functions that wasn't caught as a merge conflict, but it still broke everything. So we don't want to send clients everything, because we don't want to accidentally send off something embarrassing. But we also don't want to just flood their inbox with changes that may only be small incremental changes from the last time they saw the build. And so we have the ability to promote a nightly job. The QA team can say, you know what, this has a good set of features from the last time we promoted a build. Let's enter in some handcrafted release notes, something that is more friendly to a human, and approve this build to be sent off to the client. This re-signs the nightly build. We don't rebuild the project because we want to introduce as little changes as possible to the build that the QA team saw. So it actually takes that build and re-signs it using the code sign command line tool with the client's distribution certificate. This will also upload the build to Hockey app and send the client an email about the new build with all the release notes that were entered. And all this is done directly inside of Jenkins. This also posts notification in Slack, so the whole team is kept up to date. So our promotion process is great because it provides clients transparency into the progress of the project and gives them frequent beta builds. So the third type of job is the release job. And this is triggered manually when the client says this build is good to go. And so release truly means release to the end users. And so because of this, we require some build parameters. We want to specify the marketing version of this release. We want to specify release notes that the client has approved to send to their end users. We want to make sure that we've captured all of our debug symbols. This is going to collect all that and send them to Gap, which is also our crash reporting tool. And then it's going to distribute this build via the App Store. We can upload that automatically, or to mobile application management, or MDM, like AirWatch. We'll upload it automatically there as well. And this will also post notifications in Slack so we know what's going on. And this is great. This is great because this reduces the effort of shipping to end users, which allows us to more rapidly add new features, as well as respond to bugs when we accidentally ship something that isn't working as designed. And this workflow has been working great for our projects. It is one that has been developed over the last year and will continue to evolve over time, but this is where we're at right now. Now, to be candid, having an automated workflow is not like having an employee. It's more like having a puppy. But everyone loves puppies, so that's okay. But puppies do require training, because otherwise they peel over your rug. And for Jenkins to peel over our rug, that means sending embarrassing things to clients, or for us to spend more time working with the automated system than it would have taken for us to do something manually. And again, if I'm being honest, there are some days where it feels like it is a full-time job just to manage the system. And that's not because it's fragile. It's not because it was very delicately pieced together with chewing gum and duct tape. It's just because it has to handle a lot of different scenarios. A lot of different types of use cases will come through. A lot of different code changes, new tests being added all the time. New parameters are being changed, whether it's APIs that are changing, we need to respond to those. Xcode or Apple every now and then introduces breaking changes. Do we have to accommodate for that? So it requires continued maintenance. But again, all the time that I spent working on this, the time that it is stolen, it has more than made up for in the time that it is saved. And so I would always do it again. But part of this, and my hope to save you some of that stolen time, is to provide some tips for effective automation. And the first is honestly not even necessarily really related to automation so much as it is to testing, which is make sure that you're using the release build configuration. Which really, if I were to say this a longer way, when you are testing, use a build configuration that is as similar as possible to what you'll be sending to your end users. Because it's all too easy to forget if you have some sort of predefined macro or something else defined inside of your environment that is always true when you are testing, but forgot to make its way into the production build, and so you can't replicate the bug, but your end users can. So just get it into practice that when you're testing, use something that is identical to or very similar to what your end users are getting. The second is to just verify your app ID settings. Again, this is not really directly related to automation, but this is something that I screwed up just a couple weeks ago, so it felt like it was useful to put this in here. And it was hidden from me because all of this was happening underneath the covers inside of Jenkins. I was not actively working on this process. One of our applications that we were developing in the testing environment, it had different app ID settings than what we had configured on the client side. And if I'm being specific, it was the data protection one. The client had it set to complete protection, and we had this disabled on accident. It was not using the correct provisioning profile, which means that our clients, the end users, were seeing errors, specifically during background fetch, that we just could not replicate until we figured out what was going on. So moving into some tips that are very specific to doing automation, which is make sure you are publishing and tracking your warnings. One of the plugins that I mentioned on the slide earlier was called the Warnings plugin. I mentioned it kind of up there in very light, hard to read, great text again. This is very useful because the temptation is going to be is that once you get your build working, you usually want to go hands off and say, I'm never touching this again. That was such a pain in the butt to get set up. I'm not going to touch it again. But the problem with that is that you're going to miss build warnings that occur during the process. And build warnings eventually become build errors. And so you want to make sure that you're being very active about collecting potential problems that could be occurring inside of your application. And one way to do it, which is really low-hanging fruit, is to make sure you are tracking your build warnings. The Warnings plugin has a filter that will look through the build log that really removes this type of text that was seen on the screen earlier, and look for things that looks like warnings that is spit out by Claim, the compiler, or LLDB. Well, not the compiler, it did it's going to look for those and then track those for you. So over time, you can see across the bottom here we have build. It's keeping track of okay, we had 9 warnings for a couple builds, but then they were all resolved in build 49, and in build 52, a couple warnings snuck back in. This is a useful thing to be keeping track of. Along the same lines, make sure you are scanning your source files for TODO or FIXME comments, because not all potential problems will present themselves as build warnings. Sometimes potential problems were long forgotten comments left in the source code by a developer who meant well, but just forgot. The task scanner plugin is what is very useful for this as well. Again mentioned on the earlier slide. Because what this will do as part of the build process is scan through every source file looking for specific patterns in your code. We use TODO and FIXME since that's what we find for the most part. And it's going to publish and tell you what's going on in your project. So in this build dashboard that we're looking at here, this is probably from a continuous integration build. We see that overall, the project has 9 open tasks. That means there are 9 instances of the word TODO or FIXME in the project. And 2 of them are new this time, which means it had not seen them before. This is very useful during review because those 2 might indicate these are things that the developer meant to address before submitting the merge request, but they just forgot. Maybe they started on a Friday and wrapped up on a Monday, and they just totally forgot to implement this feature. Or maybe these are things that we need to discuss as a team. It went in as a to-do now, but really this needs to be escalated to a ticket, maybe a new feature, maybe this is a discussion that needs to take place during a stand-up meeting. Jenkins is helping bring to light all of these things that are otherwise hidden. Again, just with the warnings plugin, it gives a nice trend so you can see over time how many open tasks are in your project. I would recommend for your graph to be flipped of that where it's going down, but in this instance our screenshot is seeing it going up. My 5th tip is to implement a static analysis process. So this is really something, just the last couple months, I'm becoming more gung-ho about and really passionate about just some of the benefits that a static analysis process can have for your project, because many simple or common bugs can be caught through static analysis. These are things like SwiftLint or OCLint. These are great open source projects that I highly recommend you looking at implementing inside your projects, because what it can do is it can look for suspicious code that matches patterns of common bugs. This might be forgetting to use a return value, an unused variable, maybe a typo somewhere, or it could even detect that, hey, the documentation for this method no longer matches the method signature. Maybe you forgot to update it when you updated the implementation. It can also help look for syntactic discrepancies. Although I understand that once it gets compiled down, it doesn't necessarily matter what the code looked like. But as we work with more longer term projects where we're continuing development on it for 2, 3, 4, 5 years, we're finding that when it looks like the source code is written by a single person, it makes the maintenance and bringing on a new developer far easier. It lowers that barrier for them. So those last 3 tips are going to give you a lot of data. And so your automated process is not really meant to introduce additional overhead into your process where you have to process all this additional data. And so my 6th tip is to mark substandard builds as unstable. So Jenkins has 4 build results. One is aborted, which just means that it was canceled, but the other 3 are success, failure, and unstable. Success and failure are for the most part self-explanatory. Success means that all of the steps that you defined, and made it through all of them, none of them returned an exit code that was not 0, and it produced a build at the end. A failure means just the opposite, where at some point along the way, it expected an output, and it didn't get the output that it was told to expect. What about unstable? What is significant about a build that makes it unstable? And that's up to you to define when you are creating your jobs inside of Jenkins. The way that we do it at Float is that we look at all of those things that I defined in the previous tips, things like warnings, or the static analysis results of the TODO or FIXME. We define thresholds that say, when these cross a certain value, we're going to say that this build is unstable. And semantically, what that means for us as a team is that when we see an unstable build, that means we got to the end. It got to the end of the build process, all right, and it produced a build. But it's time for a human to take a look at this, because there might be something wrong, or not something that we don't want to be sending to our client. So this might mean, if we have more than 20 to-do items in here, we're probably not ready to send this build. We need to be taking a closer look at this and seeing what tasks need to be opened up. If we're triggering more than 5 build warnings, we need to be taking another closer look at this. Or maybe the static analysis is finding 10 results that says these are things that maybe we want to have different inside of your project. These are the points where we say, all right, this build is unstable. The QA team can still test it. They're still, totally welcome to take a look at it. But it's within the team, semantically, that means we need to have a human take a closer look at what's going on in the code, because we're not ready to send this to the client yet. With those same thresholds, we actually can also define even a build that reached the end successfully. We can consider it a failure. So let's say there were, maybe more than 15 build warnings or 50 open tasks. At this point, the build just doesn't meet the standards that we set for our applications, and so it's not even worth moving on with the process. We want these issues to be addressed with immediately before we continue on. And so the principle that I'm pulling out of this is that an effective automated workflow focuses on providing clear, detailed information. You as the developer, or you as the development team, is still responsible for making decisions for what to do with this information. The automated workflow is just being very clear and concise and open about the things that it is finding as it is building your project. So as we work towards the end here, I'm talking about moving beyond just automated builds. We already talked a little bit about how taking a look at static analysis or to-dos or build warnings are ways that you can use an automated workflow to provide more for you. Automatically sending builds to clients or automatically distributing builds throughout the team. This is more than just building something and seeing if it was success or failure. But what else can you do? What can you build on top of this? So briefly, I want to share with you just a story of a current project we have going on right now. And it has some unique requirements. The app was developed very rapidly. It had to be sent out to a number of users. But there's a piece of data in this application that needs to be updated twice a week. But we're not able to use a web service for it. Again, unique constraints. Sometimes working in the enterprise, we will have that. And the way this data gets sent to us is somebody emails us a zip file of Excel spreadsheets twice a week. And they expect a new build to go out to their end users twice a week because of this. And it's more than one Excel spreadsheet. So what this process originally looked like is this was sent to a developer, they downloaded it, they unzipped it, they opened up all the spreadsheets, they had to go through and modify the column headings so they were consistent each week, exported them to CSV, imported all the CSV into SQLite, and then encrypted the SQLite file, put it back in the project, committed it, sent it off to QA team to take a look at, and then finally we sent it to the end users. This took 2 hours initially to do, and we had to do it twice a week. It was a huge drain, and it was a huge bummer to have to deal with this, especially when we know that ideally this should be a web service. It's still not a web service, by the way. It will be soon. Eventually, this process we got down to an hour. We started writing a couple bash scripts that took care of maybe the very easily scriptable pieces, which is if I feed you a zip file, can you spit me out a bunch of CSVs? That's pretty easy to script. It just unzips, looks for everything with the Excel suffix, runs a Python script to go through and convert this to a CSV. And then it really wasn't that hard to use SQLite to say, okay, now that you have these CSV files, can you import them into SQLite? We had another script that then said, okay, if I give you a SQLite file, can you encrypt it and give it back to me? So we started building little bits and pieces that made it parts of the process easier to deal with. And eventually, we had every individual part scripted, which means we could write one script that took care of everything. And at that point, we were ready to load it into Jenkins. And so today, what used to take 2 hours, we now get a new ticket in our system that says, here, I have updated data. We have a custom build trigger that reaches out, that watches for a ticket to come in that has a zip file attachment and matches a certain set of keywords in it. The automated process automatically takes that ticket, downloads the zip file, runs through those bash script processes that we created, and then opens its own commit to the repo to say, here's this new set of data. And because we have this continuous integration process already in place, Floatbot immediately turns right back around and says, oh look, a new merge request. I better take a look at this and run our tests, run our UI tests. So we're able to see right away, is the data malformed? Because on launch, it's going to need to try to use it, and if it crashes, we know that there's something wrong. It posts back to the merge request and says, thumbs up, this looks good to go, or thumbs down, we have a problem with this. And at that point, I'm able to say, all right, this looks good, merge it in. Nightly build runs off, everything looks good to go. We're able to then run our release build to send it off to the client. So it once took 2 hours, now it takes less than 10 minutes, and I can do it all from my phone, regardless of where I am. And the only reason we don't automate the rest of it is that I still don't want to send off something that is totally broken. So I do still have at least one human checkpoint in there. So maybe you don't have this exact constraint in your project. I hope not. For your sake, I hope not. But there's other ways you can use this. I'm hoping that many of you have the opportunity to work with localization of builds. You know, the Xcode command line tool can both export and import XLIF files. And so you can automate saying, here's a new version of our application. Let's automate generating XLIF, sending it off to the localization team, watch for a ticket to come in from the translation team with the new files, and automatically import them, commit it to the project, and send it off. There are other processes that you are likely using that could be automated. But I want to give you a little bit of advice, which is it is important to truly understand a process before it can be automated. If you thought debugging, provisioning profiles, and code sending issues was hard when you're in front of your computer, it is far harder when you don't have a keyboard and mouse attached to the machine. Xcode's not even open, and you weren't even there when it happened. Make sure you understand the process before you automate it. This is why, for my previous story, we broke it up into smaller pieces. Not only does this give us an opportunity to reuse those pieces in future requirements, but it also makes sure that we understand what's going on in each piece of the puzzle, so that if it fails, we're able to fall back and do it manually, because we do understand what's going on. If we get error messages, we're able to debug the issue because we understand what the expected inputs and outputs are supposed to be at each step along the way. So, since becoming the lead developer of Float, I'll admit that it has been hard sometimes because I don't feel like I get to write as much code. It is harder for me to realize my passion of writing code that helps people. But part of automating our workflow has allowed me to realize tangential passion, if you will, which is that I enjoy building tools that helps our team become more effective. Because I honestly believe, and I can anecdotally, we've had fewer bugs over the last year. We've had faster releases. Our products have gotten better because the things that required humans to look at before, and humans make mistakes, we're able to start building processes around to just help us catch those mistakes, just helping us give more information to put into the project. So I really love talking about automation and workflow, and so I'd be happy to continue this conversation with you if you have more questions. But for now, that's all I have. Thank you very much. I've got like 2 minutes left. Is there short questions I can answer? Go.
Did you talk about, I about automating release notes, or do you just do a manual?
I didn't speak specifically to it. So the question was, how do you automate release notes? For our nightly builds, the change set that comes, Jenkins, honestly, the Hockey plugin will automatically take the change set and say, these are the release notes for this build. That's great, right? That's great for internal release for people that are technically minded. For our clients, though, we do manually write them because we want them to know that there are people working on their applications and not just machines. Yes?
So do you have to use, do you duplicate a lot of your job configurations between job types, or do you use things like pipelines?
What was that last piece?
Do you use the plugin like pipelines plugin?
Okay, so the question is, do we duplicate our jobs? So we have many projects that are ongoing, so do we duplicate the jobs in between, or do we use something like Jenkins pipeline? Today, we duplicate our jobs. We are still using Jenkins 1 internally, although we are evaluating upgrading to Jenkins 2. I know the pipeline is available in Jenkins 1. What pipeline allows you to do is define steps along the way. So you can say, checking out from SCM, this is a step. Building an Xcode, this is a step. Uploading Hockey, this is a step. And Jenkins gives a really great visual interface for this. Visual interface for the progress of it. Defining each step is much less user-friendly. We are working towards that, but today we still duplicate our jobs in between. Although we do use the environment injector plugin, and sometimes we will use what are called matrix-based projects to say that these are we can keep everything the same along this job, but these are environment variables that we're injecting in. It could be the build number, it could be the release notes. These are things we're injecting, and everything else can remain the same across the projects. 10 seconds for the last question.
Did you look at CI and GitLab solutions before going with Jenkins, such as HMIs or Circle CI, something like that?
I did a brief evaluate. The question was, do we evaluate other products first? The question?
So at least version in GitLab using solutions like HMIs that will do everything outside of your servers.
To be honest, no, we did not evaluate some of the other things that are out there. Partially because it's expensive to do some of these cloud-based systems, especially when we're using private repositories. They're not because some of the tools are a lot easier if you have things connected to GitHub, but we have private repositories that are not. And also, I did this of my own accord, and this was something that I did not have any budget for. So Jenkins is free and open source. Win, win, win. All right, that's it. Thank you all again very much.